Good morning, class. I hope you're doing well. I would like to quickly show you a little tutorial on how to do a level 1B speed and distance time graphs. Looks like 14 of you have turned it in. That is awesome for you guys. Just continue on down the page and try to get through these by Friday. For others that need to do it still, take a look at it. Come here to classwork, level 1B, open up your copy, and it says preview in present mode, because as you go through this, you're going to want to tab through so that you can see what we're talking about. We're going to make distance time graphs. And just to review real quick, anytime you make a graph using distance and time, our distance needs to be on the y-axis and our time is plotted on the x-axis. So hopefully you have some graph paper, because in a little bit I'm going to have you do one. If you don't have graph paper, don't worry, we'll figure it out when we get to it. So if something's a constant, what's that mean? It means it does not change. So what does the term constant speed mean? It means speed that does not change. And if we were to graph that, this is what it would look like. Our graph is a straight diagonal line. Some interesting things about these diagonal lines as you graph them. The steeper the line, like this red line, A, the faster the object is going. It's covering more distance in the same amount of time. So when we graph speed, we can tell if something's moving very fast or very slow based on the shape or angle of the line. The steeper the angle, the faster the object. However, that's not how things really travel. Think about it. We talked about it before we left. When you go to the grocery store in your car, you might speed up coming out of the driveway, go a little faster, slow down because there's a squirrel in front of you. You might stop at a stop sign for a few seconds, and then you might realize, hey, I better hurry up. We never really travel at a constant speed. We're always changing our speed. So this is why this graph is showing actual speed. And that's what we're going to do. The shape of an actual speed graph is zigzaggy. And most importantly, or one important thing, is what does this part of the graph mean? It means it has no motion. Time is passing, but no distance is going, so the object is at rest during this time. So if we wanted to find the average speed of this object, whatever it is, we take our formula, total distance, by looking at the graph, we can see it's 80, divided by the total time, and that would be 80 divided by 5, or 16 meters per second. And if we were to graph that, this is what it would look like. So the straight diagonal line shows the average speed, and the zigzaggy line is showing the actual speed. Here's a little summary of what we just talked about. You can read over that. Here's our formula that we want to use when calculating speed. Speed is simply distance divided by time. If we want to know the average speed where there are differences, we would take the total distance divided by total time. So what's the average speed of an 18-wheeler? That would be a semi-truck who drives nonstop for 1,600 miles from Houston to Los Angeles in 23 hours. What's his total distance? 1,600 miles. What's his total time? 23 hours. Simple division problem. 1,600 divided by 23 is 69.5. So here is where I want you guys to try to create your own graphs. But first, I want you to try and interpret these 4 lines of some snail races, believe it or not. Snail A, snail B, snail C, snail D. And at this point, you can jump out of present mode by hitting your escape key. And here, I want you to answer these questions by coming in here, looking at this graph, which is the slide before, and answer these questions. For example, what kind of graph is this? It's a distance time graph. So fill that in. And you can answer those questions as you go down the page by looking at this graph. When you get that done, now I need you to try and graph your own. Sorry, and right here is the data you're going to need. So what I want you to do is you can focus on columns B and C. And what I want you to do is try to create a graph that looks similar to this, except you're going to be graphing columns B and C. So I prefer you do this on graphing paper. That would be ideal. But I know you're at home, so if you don't, you could possibly try and do it on this little grid that I have. And you can use your drawing tools up here. So let's go ahead and try and do it here if we can. And if you have graphing paper, get that and use a ruler and a good old-fashioned pencil. We want to make our X and Y axis. So I'm going to take a line right here, and I'm going to go at the top. I'm going to come all the way down, make a nice vertical line. That's going to be my Y axis for distance. And then I'm going to do the same thing for the X axis for our time. And then ideally, we'd want to have some numbers here, but the numbers are going to be really hard to kind of draw on this grid, which is why I prefer we use paper. After you get your lines drawn, your Y and X axis, you simply go to the data that I'm asking you to use. And I'm going to practice here on column car A. And we play Battleship. And we simply plot our points. We go 0, 0, time and distance. So if I were to plot that over here, 0, 0 is always in the corner. And again, remember, we should have numbers here. So my time, I might go by ones. 1, 2, 3, 4, 5. My distance, I might go by twos. 2, 4, 6, 8, 10. As you can see, I might run out of room. But that's why we want to use full graph paper if we can. So if I was going to plot that, I simply look at my time, look at my distance, 0, 0, come back to my graph, and I'm going to add a dot. 0, 0. You can make it a little bigger. There we go. And the next one is 1, 3. Come back to your chart. You're going to go over 1 and wherever your 3 is. And you just continue to do that until all of your plots are done. 2, 6. Time is always first, so we always go over 1, 2, up 6. So let's pretend I'm going by 3s on my vertical or y-axis. 3, 6, 9, 12, and so on. You can see already the shape that this graph is kind of going to take. 3, 9, so go to the next one. Over 3, up to 9. And you continue that for each column. And remember, for you guys, all you have to do is focus on B and C. If you want to really challenge yourself, and after you're done, do columns A and D, you should have 4 different color lines on your graph. And just so you know, the next graph in the slideshow are the answers. So if you did do all 4, your line should kind of look like this. The gray one is A, that's the one I was doing. B is the green one. C is the purple one. And D is the black one, just close to gray. So when you're done, you get them all plotted out. You then try to draw a nice straight line. And that's going to be, again, hard on the computer. If you can use regular graph paper, use regular graph paper. Okay? Give that a try. When you're done, you should have a graph with at least 2 lines on it, looking like lines B and C, or the purple one and the green diagonal one. So hopefully your purple one, you see that it's taking a staircase kind of look. And then I want you to go to the next slide, and looking at this slide with all 4 of them on there, I want you to answer these questions. And you should be able to do that. When you get done, turn it in on Google Classroom. And if you have a paper copy of your graph, you can even add an image from your camera and snap a picture of it so I can take a look at it too. All right, that was a little long, but hopefully that helps you do this distance time graph assignment. Stay safe, everybody.